Now that we have shown that this is a 1 unit diameter circle, that is 1 meter, 1,000 millimeters, all the way around, the next thing we want to do is measure the circumference, which of course by definition must equal pi. So now let's wrap the 4 meter engineering tape around the circumference of our 1 unit diameter circle. You can see the engineering tape here. It's wrapped and taped up all the way around the circle. All the way around. It's snug. We have a starting point right here on one of the diameters, and we will look at the starting point will be 0 inside of the tape. We'll lift it off and look and wrap it all the way around and then measure what it comes out to be. Let's look at the starting point. So let's now line up the starting point for 0. As you can see, we lifted the tape. The start is 0, and we're going to match it up with the diameter that we previously drew. And when you slide it down, you can see that when you slide it down to where it belongs on the rim, the circumference, it will line up with the diameter line, and that is 0. There is the 10, 20, 30, 40 millimeters. So once again, right where the line is on the diameter, when you lower it down, we will have 0. So, wrapping the tape all the way around the circumference of the circle, we see that it measures 3,100, 10, 20, 30, 40, and bringing it down 44, and in between the 4 and the 5 is about 6. So the circumference is 3.1446. 3.1446. Clearly, it is not 3.141. That would be 3 millimeters shorter than what we're looking at. So the pi circumference of this circle is 3.144, slide right down there, 6. So let's take another look at the measurement of the pi circumference with our measuring tape all the way around the circumference of the wheel. As you see, it's taped up snugly around the circumference of the wheel, and if we come around to the start, we can see that we have a starting tape and an ending. Okay, it's a 4 meter tape in millimeters, and let's zero in closer and see what we can see here. Get this as close as we can. Straight on shot. Let's see, the end of this tape is, we're at the 3,100 millimeters, and we're going to be measuring the start and the ending point. So let me go around here so I can hold the tape for us. Here's the beginning of the tape measure. We can see snug is at 0. We need some more light. We can have more light. And when you lower the tape down, you see the 0 mark matches up with the diameter on the circumference of the circle. Now let's look at the end of the tape, where down here's 3100 that we already saw, and we're going to measure this distance. So we have a 10, 20, 30, 40, so 3100, 314, lower the tape, and we get to 1, 2, 3, 4. Lowering the tape, it's not quite to the 5, it's just after the halfway between 4 and 5, which leads us to believe it's about 6. What do you know? 3100, 10, 20, 30, 40, 40, 1, 2, 3, 4, we'll call it 0.5, 0.6 millimeters. That's what we show, and therefore that is the pi circumference of this circle. Pan over here to see the 3100 at the end. So we know, straight on shot, that when we lower that down, we are once again at 3.1446. Another quick look over here, hopping from chair to chair. We see, once again, it's between 44, the 41, 2, 3, 4, and 5. So it's halfway between the 4 and the 5 there, and we'll call it a 0.5, 0.6. That's pretty close for this big laboratory I have here. So you too can cut a circle, and let me give you a hint. Excuse me. You want to face the tape measure against the outer diameter of this circumference. You do not want the tape measure to become part of the circumference, or you're not measuring the outside diameter. Then the tape measure becomes part of the cylinder, and that's not valid. It would be too short. So you do want to keep the tape measure facing in and measure the outside diameter of the circle that you cut with your renting of or using the use of a CNC machine.